I'm getting a couple requests for guys struggling on the color-coded resistor calculations for the worksheets that were in the back on the review questions. So for the review questions section on page 145, the problem I got posted here is a real similar one from a different section, and it'll help you guys out who are struggling on that. We'll do a little reminder on how we calculate the resistance values for these types of resistors. So we got our color-coded chart here to refer to. Hopefully it's not too blurry. And we're going to go ahead and just, calculate the values of these resistors first. So the first one we have here, it has 3 bands. So it's got a green, it's got a blue, and then this one's actually brown. Now remember the last resistor right here, we are missing the tolerance one, which is fine, not all of them have that. But this last one, the brown one here, is going to not be calculated the same as the first two. The first two are the digits, and then the last one is going to be the multiplier. So sometimes you could have 4 bands there. It just depends on what the last one is. So this one's going to have 2 digits and a multiplier. Sometimes there's a third digit, and then there's another band here, and that's the multiplier. Other times you have the one over here for the tolerances. This is kind of the bare minimum right here. So we have 2 digit values, and then again right here we have the multiplier. So based on that understanding, let's go ahead and look at what those values are going to be. So for the green one, if we look at our coded chart, that's a 5. Oops. So this green digit here is a 5. The blue is a 6. And then the brown is the multiplier. So we're not going to look in the digit column here. We're going to look in the multiplier column, which is right here. So first band, second band, and then this one right here is optional, which we don't have it right now. The final band is the multiplier, which is what we have there. So we have 2 bands and a multiplier. So in the multiplier category, we have 10 ohms as a multiplier. So all we're really going to be doing is adding a 0 to it. We're going to multiply whatever the digit values are by 10. So here we have 56. We're going to multiply that by 10 because of the brown one. And that's going to give us a resistance value of 560 ohms. So let's look at the next one. Here we have blue, red, brown. So blue and red. So blue, we have 6, and red we have 2. So 6, 2 are our digits. 6, 2. And then again, our multiplier is brown, so that's going to be the same. So we have 10. So the resistance for that one is going to be 620 ohms. Then we have yellow, violet, brown. So again, we know our multiplier is going to be 10. Same thing on this last one. Let's go ahead and look at our digits for resistor 4. So we got yellow and violet. All right, so yellow and violet, 4 and 7. So yellow, 4 and 7, 470 ohms. And then we have violet and green. So again, violet, 7, and green is 5. 7, 5. And we'll multiply that by 10. That gives us 750 ohms. So here we have all our resistance values. We don't have a total voltage on this one like we did on some of the other ones, but we can see from the meter here, which is set to volts DC, that there's a 8.4 volt resistor voltage drop for resistor 1. So E1 right here, based on what that meter is telling us, is 8.4 volts. So with the values that I have here, there's only one that I really have enough information to solve with what's given. Let's go ahead and make some room on here, clean up. So 8.4 volts, and we have a resistance for resistor 1 of 560 ohms. So based on this, I can just input this data and I'll be able to calculate the current and the power for that matter, but let's just go ahead and focus on the current for now. So we got 8.4 divided by 560, and that gives us 0.015 amps, or move that over 3 places, 15 milliamps. Alright, since this is in series, we know one of these values is going to be the same across all the resistors. Now there's voltage drops all the way across, but the thing that we know that's consistent is the current. So 15 milliamps is going to carry across each resistor all the way back to the voltage source, since this is a series circuit. So 15 milliamps on every single one of these. Now I have two values in every resistor category, so I can go ahead and figure out what the voltage drops are on those. So if I take the 15 milliamps, which we also showed is the same as 0.015 amps, we can use that and multiply that by the resistance. So for this one, I'm going to just multiply these two values here, and that'll give me my voltage. So 0.015 times 620 ohms gives us 9.3 volts. For this resistor here, 0.015 amps times 7 divided by, times 750 ohms. Multiply these two together, and you get 11.25 volts. And then over here, 0.015 times 470, that gives you 7.05. Now from here, there's a couple of different directions you can go. We still got to find all these values, so we can solve for a number of those at this point. The easiest one would just be to add up the voltage drops and find the total voltage. So if I add this value, and this value, and this value, I should get this value. So let's do that. 8.4 plus 9.3 plus 7.05 plus 11.25 gives me a voltage total of 36 volts. Now with my resistors, I can do the exact same thing and get the resistance total because it's a series circuit. So I'll go ahead and add those up. 560 ohms plus 620 ohms plus 470 ohms plus 750 ohms gives us 2400 ohms. Or 2.4 kilo ohms. Alright, with those two values, I can take 36 and divide that by my resistance values there, and because the current is the same all the way across the circuit, I should get this value, which I can plug directly in. Okay, so 36 divided by the resistance of 2400 gives us 0.015 amps, which we know is 15 milliamps, which is the same as our other values. So that was at least correct. And now the only blanks we have left is for the power, so we need to find the watts. So for me, the easiest thing to use to find that is we're just going to multiply the voltage and the current and that'll give us our watts. So the total, 36 times 0.015, gives us 0.54 watts. Now we can do that for every single one of these. And then those should add up to this total when we're done. So for resistor 1, 8.4 times 0.015, 0.126 watts. Resistor 2, 9.3 times 0.015 gives you 0.1395. 7.05 for resistor 4 times 0.015 gives you 0.105. We'll carry it out a few more decimal places here just to make sure we get the most accurate answers. But the 3 decimal places would be fine. So 11.25 for resistor value 3 multiplied by 0.015. That'll give you 0.16875 watts. So let's add those up. So if you add each of those up, that gave us our total of 0.54 watts. So hopefully that little walkthrough makes it easier if anybody's struggling on these. And again, just practice using your resistor bands. The last one, if you're putting a digit in there instead of the multiplier, you're going to get the wrong resistance values. And you're going to obviously be off to a bad start there. All right.